Okay, here we go. So it says 20B, measuring the center of data. You actually already know most of this stuff. Now, 20B is separated into B1, B2, and B3. This is only the notes for B1 today. I know it doesn't say that up there because this is the title for the whole section. And there's not like a separate title for B1, but this is only the notes for B1 today. Okay, you got your setbacks? So, the reason why I said you guys know most of this stuff is that the three statistics that are used to measure the center of data are the mode, the mean, and the median. What do you guys already know about the mode? Occurs the most. So we're going to review that very briefly. What about the mean? The average, do you guys know how to calculate the average already? So add up all the values, divide by the amount of values. That stays the same too. We're going to get a formula that looks scary but isn't for the mean. And what do you guys remember about median? The very middle number. So that stays the same as well. So again, a lot of this is review. We're just going to have a few different tips or tricks, slight changes. Also, does anyone have it like ingrained in their head that it's always mean, median, and then mode? Yeah. Okay, just read carefully. When you do your assignment, it might not always be in the traditional order. Like this is not in the traditional order. So I remember I did my assignment and then I had them written down in the wrong areas and then I like looked in the back and had the wrong answer. Well, I didn't. I just had them out of order. So pay attention. We're going to start off with the mode. So we touched on this yesterday. So for the mode, there's kind of two different types. If you've got discrete numerical data, remember we talked about that yesterday, that is like if you have just those whole number answers, those positive integer answers, the mode is the most frequently occurring value in the data set. So whatever number shows up the most is the mode. And again, that's the mode because we've got those individual values. But we talked about another type of data. What was the other type? It's not discrete. Yeah, continuous. So, like I said, we did touch on this yesterday. It's continuous. So for continuous numerical data, we can't talk about the mode the same way because in continuous, it's not just one value that's the most. It's a range or an interval. So instead, it's the modal class. This is a typo I forgot to fix. It shouldn't be modal. It should be like modo with AL. I don't know if I caught it by the time I had your class yesterday, but it should be AL. Anyways, so it's that modal class. So it's an entire group. It's not just one value that's the most. It's like a range of values. You know, heights from 60 to 62 inches are probably not the most average because that's kind of short, but you know, this is an example. There are no tips or tricks to mode. Like you have to just see what is coming up the most. You know, if you've got a frequency table, it's going to be the one with all the tally marks or the highest frequency. If you've got a histogram or a column graph, it's the tallest one. So I mean, those are some visual ways, but not really anything new besides the idea of a modal class when it comes to mode. Up next is the mean. I'm going to zoom in on these things so you don't have to start scribbling all down right now. But up next is the mean. So it's the definition is that it's the statistical name for the arithmetic average. Which you guys already told me that. as you guys also already told me, the mean is the sum of all the data values over the number, divided by the number of the data values. You add them all up, divide by how many there are. That is also the same. We're not really changing that whatsoever. We are going to show you a formula that means this exact same thing, but looks a little scary. So before we get to that, it's in a couple of slides. Do you guys remember a symbol that represented sum? Back from like chapter 6, there was a symbol that means sum. Oh, okay, yeah, we did have the S, but I'm thinking of a different one. Someone in second hour shouted out Soviets. I don't know if that is memory. It kind of looks like an E. Yeah, it's called sigma, but you know it looks like this. Yeah. I definitely told you that in chapter 6, section E. Well, it means sum, or I mean it's sigma. It's a Greek letter, so you know that's that. But remember, that just means you're adding them all up. So don't get panicky when you see that symbol. It just means, hey, we're adding all that stuff. So one thing to know is that the number is not usually a member of the data set. Like I could, you know, if I'm looking at all of your test scores and I'm looking for the average might be like an 83.4. Well, no one got a score of an 83.4 because I always round them to the nearest integer. But, you know, that's what this is saying, is that the mean is not usually a number that's in that list. It's not impossible, but not usually a number in that list. So the next screen is got that funky formula. I don't want you to scramble and try to write it all down. I'm going to underline the absolute most important things that you need to write down, okay? And I'm going to explain the formula. It might be helpful to write it just so that you recognize it if you see it again. But again, don't panic. So X is just a number in the list, okay? X is just one of my numbers in the list. So Xi is the I data value. Don't freak out about that either. That just means that X1 is the first number, X2 is the second number, X3 is the third number, okay? This is the important part, or I skipped N. N is just the number of data values in the sample, so N is how many numbers are there. This is important. We call this X bar. X bar represents the mean of a sample. So if you have a sample, remember that's where we can't survey all of the households that have cats. We're just going to survey some of them, right, from yesterday. So that means average. So if you see this X bar symbol, it means mean. It means average. So the formula then is if we add up all of them, so X1 plus X2, the first number plus the second plus the third, all of them, and divide them by how many. So this is the same thing that we had written out in words before. But then this is like the formula, and again, I guess I would just jot it down so you don't get like freaked out if you see it. But it just means the sum divided by how many. It's the exact same thing that we wrote down before, just in mathematical symbols. And when I first looked at it, I was like, that's doing the most. Like, we just add them up. Like, why do we have to have this? But it's important that we can understand and read it, you know, algebraically or mathematically as well. One last important thing that you should write down from this slide is this other symbol here. Have you guys seen this one before? It's called mu, which is why we have this lady sharing that information with us. It's another Greek letter like sigma or theta, but mu represents the mean of a population. Now it's a very subtle difference. And it turns out that they are generally the exact same thing and the exact same number. You'll notice that's the exact same formula that I circled in red. So we just use X bar when we're not doing the whole group. We're just taking a sample, and then we use mu to represent the mean of the entire population of everybody. So we'll talk more about that in future sections, but just those are the important things that you should jot down from this slide. So we don't usually have all the data, like it's really hard to like take a census for the entire population, so usually we find the mean of just the sample. We are going to kind of switch and talk about median next, like that's all the mean information. But are there any questions or concerns? Trying to make this not freaky. Okay, so the median is the middle value of an ordered data set. I'm just going to zoom this in a little bit for us. So it's that middle value. In the past, you guys remember we line them all up in order, so it has to be ordered from least to greatest. If you have an odd number, an odd amount of values, then the median is one of the original values. Because if we have an odd number, we don't remember crossing them out until you get to the middle. So if you have an odd number, there's just one number in the middle. But if you have an even number of data, like an even amount, then it's the average of the two middle values, probably not in the original data set. So, if we have an even number, we cross them out, and then we have two values in the middle. Do you guys remember doing this way back then? Way back when? Not then, I can't tell a specific date. There is, I think, kind of a shortcut little formula that we're going to get. I mean, you can still cross them out. I'm not going to say you can't cross them out. If that's a tried and true method that makes sense to you, you can keep doing that. But I found the formula to be just a little bit quicker for me. Made things a little bit faster. All right, so here is the formula. If there are n data values listed in order from smallest to largest, the median is the n plus 1 divided by 2 data value. So let me explain it in different terms. Let's say we've got 15 numbers in our list. 15 would be the n, that's how many there are. So 15, what's 15 plus 1? Come on now. Okay, 16, what's 16 divided by 2? 8. That means the median is the 8th number in the list. So to me, to do that little formula really quickly, add 1, divide by 2, I didn't have to do the crossing out because I could just count and be like 1, 2, 3, 4, 5, 6, 7. The 8th one is the answer. And we'll do an example where I show you how we go about that as well, just in case you're interested in using that. But let's say we have an even number, like let's say I had 20 values in my list. Well, 20 plus 1 is 21. 21 divided by 2 is 10.5. So that means that the median is between the 10th and 11th numbers, so I just add those two numbers up and divide by 2. So I thought it was a little quicker than the cross out method. Okay. Questions? All right. So we do have one more thing we're going to look at, but a lot of what we did today was review. Explain one new thing you learned about an old topic. So what's something new that you learned today? The median, yeah, that one was the biggest one for me too. I felt like it was the most helpful. And that's okay if that's all we got. Okay. Let's see. I'm skipping this, so don't panic. We'll be fine. Okay. This is straight out of your book, so I wouldn't try and jot it all down. But this just kind of is talking about the mean and the median and different distributions. So, we talked about symmetrical distributions and then positively skewed and negatively skewed. So if you have a symmetric distribution, the mean and the median are both pretty good measures of center because they're usually right in the middle there. Now, if it's not symmetric, if it's positive or negatively skewed, then, the mean might not be actually in the center, and even the median. So it might be skewed a little bit differently. So if you've got these skews, the mean might not be the best measure. We'll take kind of a look at that and sort of learn that as we go as well. Okay. One thing I've discovered is that we are not going to be able to do all of those together. So we will be doing some of those together. You should still complete them all that are in this top list. Remember, this is your assignment. I think we got through those 5 earlier today in second hour. I do need to talk about some end of the quarter things at the very end of the hour, so I'm not going to be able to go right up to the bell with like your homework. So we'll see how that goes. Okay, are we ready for trying some homework? Okay, I don't have them cut out of the textbook today, so you guys should have your book out so that you can take a look at those values. Actually, we did not do 1. We skipped 1. We did. Yeah, we're going to start with 3. We were only able to get 4 of them done together. Number 3 lists the annual salaries of 10 office workers. Part A says find the mean, median, and modal salaries of this group. What do you guys want to do first? You have to find the mean, median, and mode. What would you do first? Okay. You want to do the mean first? I was really surprised. I thought you guys were going to say put them in order first. No? Yeah, I said, what do you want to do first? You could say, I want to take a nap, but don't say that. It's definitely, if you have to find the median, you want to put them in order. So, are you guys okay if instead of writing all the zeros, I just write the first 2 digits and we know everything's in the thousands? Mm-hmm. Okay. So, putting them in order, I'm not gonna lie, I did this is my 3rd time, so I remember the order. For the most part. Yeah, except for the most part. So I just jot a little note down that we are in the thousands. One thing that is a really good idea that might seem silly is that after you order all of your numbers, to count them and make sure you have the same amount. It's so easy to just forget one. Like, just accidentally forget one. So, we should have 10 values. It says there were 10 salaries. Sure enough, I've got 10 values up there. That's a little step that will help you in the long run. I would also say it helps to jot some of your work down. Now, there's something that's kind of tricky with this chapter that Ms. Krantz and I are still figuring out is we need to incorporate some TI-84 graphing calculator stuff in, but only about half of those are working right now, and I'm still in the process of locating batteries to get the other half to work. So, turns out we can actually plug this into a graphing calculator and it'll give us the mean and the median, without doing any work, though we still need to know it by hand. So we'll be incorporating some technology as we go. We're just still kind of working on, how we're gonna do that. So when you add them all up, what do you guys get? What'd you get? 293? Anyone else? Then you will have to put the zeros in. So highly recommend writing down what you got. So those are those zeros back in. Because it's so easy to just punch something wrong in your calculator. I added this up and I added it up wrong twice. I don't know what I punched in my calculator wrong, but like it's very easy to make a small mistake that doesn't mean you don't know what you're doing, but you're just, having some calculator problems. How many am I dividing by here? 10. So the mean salary then is $29,300. So I'm going to use the shortcut for the median. So for the median, I have 10 values. So I've got 10 plus 1 divided by 2, which is 5.5. So that means 1, 2, 3, 4, 5. The median's in between those two. So I would take 23 plus 24 divided by 2. And then I changed it into the thousands as well. So you can definitely do the crossout method if you like the crossout method, but did you guys see how that worked? So 5.5, so it's between the 5th and the 6th numbers in the list. No shortcuts on mode. What's the mode? 23,000. Now there's 2 follow-up questions after we find the mean, median, and mode. So this is 3A. Any questions on any of those? Like if you cannot calculate the mean or the median or figure out the mode, we gotta talk more about it. Okay, so part B says, explain why the mode is an unsatisfactory measure of the middle of this data. So why is the mode probably not a good one to use? It's skewed. Well, yeah, we'll talk more about that too. Well, what is the mode? We'll go down, 23,000. One thing that's kind of strange is that's also the lowest value. So because of that being skewed and it's the lowest value, it's not really a good measure of the center because the mode's towards the lowest value. Okay, I think this last one is kind of confusing. It says, is the median a satisfactory measure of the middle of this data set? So why are you shaking your head no? Oh, so yeah. Absolutely. So because it's very close to the mode, it's very close to the lowest value, it goes back to it being positively skewed. We are very much positively skewed here. So that's going to make the median not a really good representation either. And it's okay if you don't feel super confident about that question just yet. Remember, when you're doing your homework and doing the problems on your own, give your best guess and then check what they say in the back and kind of compare and use that to help you learn more of what's going on with these types of questions. Number 5 is next, if you guys are ready. Number 5. Okay, so it's about another basketball squad. So number 5 says a basketball team scored 43, 55, 41, and 37 points in their first 4 matches. So part A is just find the mean. So I'm going to write these down. Let's go ahead and find the mean. You guys should be able to do that without much assistance. So what did you guys get when you added them all up? What's the sum of all of the scores? What did you get? Oh, I was 26. Yep, 176, and we have 4 values. So when we divide that out, we get exactly 44 points for that average. So they had 44 points. Again, make sure you are writing some work down and checking your work. For some reason, I added this up wrong, and then it threw off every single one of my other answers. So be careful, check your work, go check back at your calculator if you're not getting the same answer as the back of the book. Okay, so then part B says, what score will the team need to shoot in the next match so that they maintain the same mean score? So they have another game coming up. What score do they have to get in that game so that their average is still 44? So we're going to have another game. Oh, I feel like, yeah, it is. How do you know that? I feel like I'm not smart enough to know that. So you explain it to me. I did it all algebraically, but I'm starting to understand it, so explain it. That makes so much sense. That's how you can do it without any work. Logic. Love it. I completely missed that. I shouldn't have missed it, but. So Michael gave us some logic, like obviously to keep it the same, it's got to be 44 points. Let's say that we don't have this logic, and I just want to show you this just because I think this is going to help for a future problem. It will help for number 11. How many games total are we going to have? 5, because we add another game. We want it to equal 44. We have to divide by 5 now. So 176 plus whatever that is. X is the 5th game. We don't know what it is, right? So then how would you go about solving this? So multiply by 5. I'm really glad that Michael helped us out with equipment though. But just for future things when this will come into play, we'll go through the rest of it. So kind of proving Michael right when we subtract, we get, sure enough, 44. You know, someone in second hour asked me, like, will it always be the same? And I was like, no, it's just a coincidence because I wasn't getting it. I get it now though. You just tell my second hour. Okay. I'm gonna upload this video, so it'll be good. Okay. Now we figured that out in a much easier way, but we still know algebraically how we could prove ourselves if we had to. It says the team scores only 25 points in the 5th match. Find the mean number of points scored for the 5 matches. So now we know that X is actually 25. So when I add 25, I end up with 201 divided by 5, which is 40.2 points. So they only scored 25, so their average went down to 40.2. So the last part says the team then scores 41 points in their 6th and final match. Will this increase or decrease their previous score? If they score 41, is their average going to go up or down? How come? It's greater than the lowest number. And it's greater than the average. Because 41 is greater than the average is going to go up. So then, if it says also, okay, calculate the mean of all 6 matches, so 20 or 201 plus that 41 divided by 6, so this is the first 5, plus the 6th one. We end up with 201 Yep, 40.3 points. So it just went up a little bit for that average. Okay, 6 is going to go by really quick, and then I'm going to get you started on 8, and then we do still have a little bit of time for my other things I want to finish up with for the course. Yes?
Why don't you count it? Because you can't get a 0.3 for 40.
I think right now we're going for 3 sig figs. Though I will say I found some discrepancies in the text where, like, if it's a dollar amount, they're leaving it to, like, the nearest cent instead of 3 sig figs. So we are going to have to deal with that moving forward. But I think that's what we're going for is sig figs. Because this would be 44.0 because it was exactly 44. That's the best answer I got right now. If you find a better one, let me know. Okay, so number 6 says, this year, the mean monthly sales for a clothing store have been $15,467. Calculate the total sales. So it's 15,467 was the average monthly sale was that much. How do I figure out how much they made the whole year? Yeah, well, times that by 12 because there were 12 months. So that was not so bad, right? Does that make sense? Some of these I can't tell if it's like too easy or if we need to go over them. I don't know. Now, number 8 looks scary, but trust me, it is not. It says that the average is 11.6 and that the number of values is 10. And it says find this. Like that looks a little scary, right? I don't necessarily feel like you need to write that all down, but that's what's in your textbook. But remember, we talked about this, that the average is equal to the sum over the total. So basically what we're going to do is we're just going to plug in these two numbers and get that big sum by itself. Like, don't panic about this. This is just the sum. Treat it as like one thing. So I have 11.6 equals the sum divided by 10. Now what would you do to get the sum by itself? Multiply by 10. So it's not as scary as it looks. Just gotta multiply that one. But I figured that one might freak everybody out. Okay. We are going to talk about end of the quarter business. So you guys will have to finish the rest of the assignment on your